You got it? Thanks. Let's begin with a word of prayer. So, dear Heavenly Father, we thank you for this day. We thank you for your many mercies to us and your grace, which you give to us so freely. I just pray you bless this class, Lord. Help us to understand the tests that we just went over, when we just participated in. Help us understand any questions that remain, and I just pray you be with us today as we cover the new material. That you be glorified, Lord, in what we do this day. In your name I pray. Amen. Okay, guys, so go ahead. What's your first question? Which one? The latter one. So the latter one basically goes like this. So I think of this as being y, I think of this as being x. This is 10. So we know that x squared plus y squared is equal to 100 in feet, right? And then if I want to understand what's given here, I'm given that dy dt is minus 3 because it's decreasing, right? And I'm also given that x is equal to 6. So these are what's given. And I'm trying to find out dx dt equals what, right? Okay, so what you do, here's the Pythagorean Theorem, differentiate this thing. We get 2x dx dt plus 2y dy dt. Some of you had an s squared over here. In fact, a lot of you had an s squared over there, which would be if I had made the ladder a variable length. But I didn't do that. I'm not a monster. The length of the ladder was 10. So you just put 100 there. And then that gives you that dx dt is equal to minus y over x dy dt. Right? Now, notice if x is equal to 6 and x squared plus y squared is equal to 100, that tells me that 36 is plus y squared is equal to 100, which tells me what? Yeah, y is equal to 8. So I put that in down here. I get minus 8. X was given to be 6. Dy dt was given to be minus 3. So I get 24 over 6, which is 4. So the answer is 4 feet per second. And that makes sense. These positive because the x is increasing, right? But the y is decreasing. But no, I think if you had minus 4 feet per second, I still gave you credit. I don't know if anybody did that. Any questions about this? No? Does that make sense? Of course, I will post a solution sometime soon, right? Did I already do that? I hope I didn't, because my current solution has a couple errors in it I need to fix. So, anyway, next question. Yeah, now number 9 is not much to this one here. You're supposed to calculate the differential for f of x is equal to 3x squared plus 7 to the 6th power. And so by definition, df is f prime of x dx. All right, so what's that? That is 6 times the quantity 3x squared plus 7 to the 5th power times 6x by the chain rule, right? If I differentiate this, my outside function is the 6th power, inside function 3x squared plus 7. 3x squared plus 7 differentiates to 6x, and then dx. So, I mean, I guess you can rewrite this as 36x times, I mean, you don't have to. I think I'll probably write my answer like this. So there it is, that's the differential. Of course, this is useful for like estimating error. If I knew that the change in x was 1 and x was equal to 2, then I could plug in dx is 1 and x is equal to 2, and that would give me the approximate error in the quantity f, for example. Next question. Now, I had written the differential up on the board during class. So, what's that? Number 4? Yeah, a lot of you got number 4 wrong. Number 4, very, very popular question to get wrong. And I think all you can do that. I think it's just the test, test-induced silliness. So here, f of x was equal to what? It was equal to x squared plus 6 to the 10th power, right? And so you guys have a habit. Well, I think the thing I saw a lot of is people started off on the right foot. Like people were like, okay, so f prime of x, I got this. F prime of x is what? It's 10 times x squared plus 6 to the 9 power times what? Times 2x, right? Now here's where we got you. So f prime of x is what? It's 20x times x squared plus 6 to the 9th power. Okay, great. It wouldn't have really mattered if you collected the 20 and 2 times 10 is 20. That's not so much the point. The point is, when you do the next derivative, what has to happen? Yeah, there's a product of functions is the thing, right? This is a function of x, that's a function of x. So when you do the second derivative, you have to do the product rule. And so many of you were doing the, here's the product rule, which is often practiced on the test in the midst of not thinking, this is not true though. So don't do that. We have to do is no bueno. Okay, so f prime prime of x is 20 times x squared plus 6 to the 9th power plus 20x times 9 times x squared plus 6 to the 8th power, again times 2x. And you could clean it up, right? You could simplify it, but that's the main point there. Yeah. I'll write a simplified answer on my solution that I'll post. But so almost without exception, people who got this wrong, it's because you didn't do the product rule in the second derivative. Make sense? I mean, it doesn't make sense to not do it, but we can understand what happened, right? Yeah. Don't feel too bad if you made that mistake. You have lots of good company. Many of your peers. Yes.
Question 11. You said 5 intervals. What? I got like the graph and the maximus, right? What do you mean?
What's in?
Intervals?
Sure. What? So, yeah, let's run through here. Number 11, you have g of x is 2x cubed plus 3x squared minus 36x, and we're supposed to find intervals of increase, decrease, blah, blah, blah. And interval means something, right? Like an interval is an interval of real numbers. So what is an interval of real numbers? So just to, here's a number line. If this is 1 and this is 3, this is a picture of an interval. What's the interval, though? This is an interval, right? Or you could have something like minus infinity to 3 included. That's an interval. This is interval notation, right? So I was asking for the intervals. Anyway, so this, when I differentiate, I get what? I get 6x squared plus 6x, which is 6 times x squared plus x, which of course is 6x times x plus 1. So if I set that equal to 0, I get critical numbers x equals to 0 or x equals to minus 1. Put that on a number line. There's my critical numbers, and well, the derivative is a parabola which opens up, so it's going to be like this: plus, 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 minus, 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 plus, plus, plus. So g is increasing on minus infinity to minus 1 and also 0 to infinity. And g is decreasing on minus 1 to 0. Whether or not you include or exclude the points where they're joined, I don't really care. You could include or exclude them. It would still be right. What happened here? I have made a mistake. Huh. Hey, this problem is still pretty nice if you drop off the x. Check that out. This would have been a good typo to make on your solution, right? Like, you've been lucky if you'd copied the problem down wrong like this, because you could have shown me you understood the material and it would still have been pretty easy. Yeah, okay, so I've lost the x, huh? Fine. Shall I fix it? All right. These guys are just mean to me. All right, x. Why didn't you guys stop me back there? Why let me go on like this? You monsters. Let's see here. Saving my marker. All right, so this is minus what? 36. So I can factor out a 6. Which is what? 6 times x plus 3 times x minus 3. So my critical numbers are minus 2, right? Our x equals to minus 3 and 2. Those are my critical numbers. And so I put those over here in the right order, minus 3 and 2. And so I get that it's increasing from minus infinity to minus 3 and also from 2 to infinity. And it's decreasing between minus 3 and 2. So, of course, the first derivative test tells us what? So it's like going up and then going down. This is a max, right? This is going down and then going up. So this is a min. So the graph, roughly speaking, I don't know, it's something like this. Roughly speaking. I guess I should make it go through the origin, huh? Now, if you look at the solution I'll put in Blackboard, I'll actually have a little bit more detail here in terms of actually telling you the points where the min and the max is. Right? So the best graph actually would have those points labeled and, you know, be a little bit more careful than what I wrote there. I wasn't super critical. If your graph was kind of generally in the ballpark, I didn't take points off. If your graph looked like a, I don't know, it's hard to describe the wrong graphs I saw. Then again, I'm also thinking about Calculus 3 where I saw other wrong graphs, so it's hard for me to remember which one from which class. But I don't know. It should look something like that. Yep.
No, I was just saying I was wrong because it looks
Like a bird. Oh yeah, that's the one I was thinking of, the bird one. that bird one was awesome. I did enjoy the bird. I should have given you a bonus point. Okay, so what's the next? Any other questions? Let me go on and start the new material. I will post a solution to the rest of the problems, and of course you can come to my office hours and talk to me about your, whatever went wrong. If you have questions, it's fine. I'm generally speaking pretty happy. I think you guys, a lot of you are understanding. Some of you are not, but there's still hope. So just keep working. So our next topic is optimization. So let me start with an example. start with an example. So let's suppose we're given that a function looks like this, all right? And I'll tell you these points. This point is 1, 8. This point here is 5 minus 4. This point right here is 7. I guess it's 9. And let's see here. This point is 8, 2. All right. And then here's the question. Find extreme values for f of x on the closed interval let's say -1 to 8.5. So what's an extreme value for a function? What does that mean? It means it's like the biggest, minimum or maximum, right? Minimum or maximum, biggest or smallest. But when I say smallest, I really mean the largest negative, right? Some people, when you think smallest, you think closest to 0. We don't really care about that, right? So we want basically we're looking for the largest magnitude possible in the graph, right? The furthest away from the x-axis for this problem. So, but the interval of consideration is important, right? If I change the interval we're thinking about, then we get different answers, right? Now, let me just draw. We're looking at this piece right here, right? Something like that. That's what we're considering, just that red part. So how do you figure out what the extrema are? Yeah.
Just from looking at the picture, you take the absolute value of all the y values.
Right. Now, I guess if you're a mathematician, you'd say, I don't know. I don't even know what you're talking about. What does this picture mean? Well, fine. You got me. This is y equals f of x. Fortunately, there are no mathematicians in the room, so no one sarcastically told me that. Yes? So you said just look at the picture, right?
You take the absolute value of the y, whatever is the
Yeah, let's see here. So what's this picture tells me f of 1 is equal to what? 8. F of 5 minus 4. F of 7 is 9. What's up with this? I keep forgetting to... f of 8 is 2. And then there's something else I should tell you about. Let's suppose that this point's also given. That's 8.5, comma 2.5. And this point I also really should tell you that point is -1 and, I don't know, 3. Right? So these ones, and then these other ones are special. F of 8.5 is equal to 2.5, and f of -1 is equal to 3. So how do you figure out which is the extrema? It's very simple. You just look at the list and you pick a winner and you pick a loser, right? So what's the winner here? There we go. So that's the maximum. What's the loser? Or, yeah, that right there is the minimum, right? All right? Now let's just take a step back and think about what we did. What's the method? There are two kinds of points we're looking for. Endpoints, right? And these ones are local extrema. In other words, the points where the derivative is either 0 or undefined. Now, technically speaking, to be sure I have an answer, I need to know that f is continuous. If f is not continuous and I try to find the extrema on a closed interval, I may be on a fool's errand. It may not be possible. For example, if I have f of x equals to 1 over x, and I try to, say, find extrema on, -1 to 1, well, that would be very hard, right? Because f of x does what? It's like this, and it's like that. So if I just look at, this piece like here and this piece like here, as you can see, there's no minimum and there's no maximum, right? So that would be very hard to do. But that's because f is not continuous. Yeah. Oh, good. Glad to help. Let's see here. Now, there actually is a homework problem which is more or less like this, all right? It gives you a graph and it asks you to find the extrema, right? I think you don't need me to teach you how to do that, right? I think everybody can do that, right? Right? Please agree with me. Thank you. There is, of course, one possible place of misunderstanding, which is what is the connection between the value of a function and the points on the graph, right? You do need to know that these correspond to those, right? And there is another point of language that is sometimes important to understand the distinction, where the maximum is at as opposed to the maximum value, right? So a maximum of 9 is attained, right, at x equals to 7. But the maximum value itself is 9. Where it happens is x equals to 7, right? So okay, so let's look at an example which we can't solve quite as easily. Let's look at f of x equals 2. And let me try to find one somewhat similar to your homework. We're on homework what? Man, homework 10. Time flies when you guys are having fun, huh? Let's see here. Let's see here. I've got, here we go. 1/8 x squared minus 4 times the square root of x on 0 to 25. I forgot it already. So this is actually number 6 in your homework. There's other problems before this, which I'll address here shortly. Whoa. And so the problem here is to find the extrema or the extreme values for f of x on this interval, okay? So how do you do it? 25. 25. 25. So what's the method? The method is we need to do two things. We need to find critical points, and we need to check endpoints. Now, so how do you find critical points? Well, same way as before the test. F prime of x is what? It's 1/4 x minus what? 4 divided by 2 square root of x. See, this is interesting. The derivative is not defined at the left endpoint, right? At 0, this function has a vertical tangent. But that doesn't really matter. We're mostly interested in the interior. You know, here we're looking at x in the open interval. All right. So, or just more to the point, this calculation is for x not equal to 0, right? Or even more to the point, it's for x greater than 0. Okay, now, So I want to, how do you find the solutions to this equation? What do you do? Factor? We could do that, I suppose. I'm going to be lazier. I'm going to say x is equal to, well, let's say 1/4 x is equal to 2 over the square root of x, right? Which tells me what? That tells me x is equal to x squared of x is equal to 8. So that's x to the 3/2 is equal to 8. Notice that x is positive here. So that's nice. That means that we don't have to worry about pluses and minuses so much with square roots here. So x is what? X is equal to 8 to the 2/3 power, right? What is 8 to the 2/3 power? In other words, the cube root of 8 squared, which is what? 4, yeah. Okay, so in order for that to be a legitimate contender for being an extreme value, it actually has to be in the interval of consideration, right? So is it in 0 to 25? Indeed it is. So we should figure out, okay, so let's see. Calculate f of 4 is what? 1/8 of 16 minus 4 times the square root of 4, which is what? What'd you guys get for that? -6. All right. There we go. Are there any other critical numbers here? No. I mean, that's it for local extrema in this example. So what do we need to check? Check the endpoints. So what do those give you? F of 0 is what? 1/8 of 0 squared minus 4 times the square root of 0, otherwise known as 0. What is f? What's the other endpoint? F of 25. Ugh. All right, fine. That one I might actually have to get my calculator out for. F of 25 is 1/8 25 squared minus 4 times the square root of 25. So what is 625 divided by 8 minus 100? Wait a minute, no, minus 20, yeah. I don't know. I guess it's 625 minus 160 over 20. I don't know. Yay, thank you. I'll take it. All right, so let me draw your attention to the 3 important things. This, and I'm just writing the source of that number 4. So you've got these 3 contenders, the endpoints and the local extrema. This function's continuous. That's a closed interval. We must find a min and a max. What is the min? What's the max? Very good. And that's how you do it. Does that make sense? Do you see the algorithm here? We take the closed interval. We find all the critical points in the interval. We check the function at each critical point, make a list of those values. Then we check the function at the endpoints, and then we just compare and we select the min and the max. Yeah.
Couldn't it also be a -2 when you're square root of 4? It would be 16 divided by 8 minus 4 times -2.
But it's 4 times square root of 4, which is 4 times 2, which is -8.
But the square root of 4
No, it's defined to be the positive 2. Well, your high school math teacher must have had a course in complex variables shortly before he taught you, because in complex variables, I would say this, in complex variables, I would agree with that 4 to the 1/2 is equal to the square root of 4 minus the square root of 4. But I make a distinction between 4 to the 1/2 and the square root of 4 in complex analysis, where the square root denotes all possible values for the square root function, well, multivalue. Why am I talking about this? Do not tempt me. All right, so let me go back to your earlier homework problems. There is also the notion of global minimum or maximum. So, for example, f of x equals to x squared plus 1 versus f of x equals to 1 minus x squared. Right? So here we have this. Here we have that. Right? So this right here, which is what? 0, 1, is, that's the critical point, but more to the point, f of 0 equals to 1 is the global what? Here, f of 0 equals to 1 is the global, so this is the global minimum. This is the global max. All right. Now there doesn't have to be, what's the global max for this one, the first one? Yeah. Global max does not exist. Over here, global min does not exist. Make sense? Let's look at something a little bit more interesting. Then we'll get to word problems. I know you guys want to get to word problems. So this is like number 4. Oops. Something like number 4 on your homework. So here I have f of x equals to x divided by 4 plus x squared. And we're supposed to find the absolute max or absolute minimum value, if any, of the function. All right? So, I think that the answer really to these questions comes from making an accurate global graph for the function, right? If you can make the graph for the function, then you can answer this question. How do you make a graph for a function? Well, we kind of already talked about that, right? So how would you graph this function? Yeah, I think finding the derivative is a good idea. I guess I would observe, one thing I would say is, well, f of 0 is equal to 0, so it crosses the origin, right? There's some low-hanging fruit I can see from the formula right off. Calculate the derivative, I like that. F prime of x is what? It's 1 times 4 plus x squared minus 2x times x divided by 4 plus x squared. Now, is there any vertical asymptote, by the way? No, yeah, oh, thank you. No vertical asymptote because what? Right, x squared plus 4 is not equal to 0 for all x. Oops. for all real numbers. All right, so yes, thank you. I do need to square the denominator. Okay. But is there a critical point? Maybe there's a critical point, right? Let's see here. What do we got? We've got ourselves x squared plus 4 minus what? 2x squared divided by 4 plus x quantity squared, 4x squared squared. Aha! Well, that looks like 4 minus x squared divided by 4 plus x squared squared. Okay, let's get to the point. If this is equal to 0, that must mean what? Right. I mean, the only way a fraction can be 0 is if the numerator is 0, right? So you say 2? So if 4, well, I don't know. How do you want to solve this? I'll solve this way. 2 minus x times 2 plus x is equal to 0. So you see, yeah, x equals to 2, or x equals to minus 2. Those are critical numbers here. So you're half right. It's not bad. And okay, so what's the sign chart if I want to look at that? I think I do. Let's see, that's always positive. And this is negative except for when it's positive in the middle. So this function is like, it's decreasing, and it's increasing between minus 2 and 2, and then it's decreasing again. What are the horizontal asymptotes of this function? The horizontal asymptotes are just y equals to 0, because if you look at it, the limit, I mean, here's the intuition that I have for it anyway. F of x is essentially what? It's essentially x divided by x squared when x is really, really big, because when x is really, really big, the 4 doesn't matter. So it's essentially just like x over x squared, which is like 1 over x, right? Which goes to 0. So like asymptotically, after a long time, this function just looks like 1 over x. Anyway, long story short, here's a graph. Let's see here. So 0 is a point on the graph. I guess we probably should figure out what is f of minus 2 and what's f of 2. F of minus 2 is equal to what? F of 2 is equal to what? I'll take it. Negative 1/4. And what's the f of 2? One-fourth, yeah. So, all right, so let's see, 2 and 2. So f of minus 2 is like minus 1/4, let's say. F of 2 is 1/4. I never really care too much about the scale. I'm just trying to get a qualitative picture of what's going on. And so what the graph has to look like then is something like this. It never crosses the x-axis again because the only 0 is 0, right? Notice that the only way f of x can be 0 is when x is equal to 0. So that's the graph. So what that means then is that f of minus 2 equals to minus 1/4 is global what? It's a global min. And f of 2 equals to 1/4 is the global max. This one's actually kind of interesting. Let me ask a mean example. I mean, it's an easy example, but it's a mean one. This is kind of a subtle point I'm making in this example. So we'll see if you can see through it. I'm not sure I've made definitions carefully enough in here anyway. But what we're looking at is the volcano graph, y is equal to 1 over x squared, right? So if you like, that's f of x. For x not equal to 0, obviously. Find the global minimum and global maximum for this function. And I think everybody, pretty much everybody's going to be like, there is no global maximum. That's obvious, right? No matter how high you go up that volcano, there's still more above you, right? There's no global maximum. Clearly, global maximum does not exist. But what about a global minimum? We'd like it to be what? Right, but if you set 0 equals to 1 over x squared, right? I mean, well, this isn't, I wouldn't say this is, I would say there's no solution, right? So if you try to solve this, this gives you 0 is equal to 1 if x is not 0, and so it's like, no solution. So, right, but if it's not actually reached, it's not the minimum. It is what's called the, let's see here, the greatest lower bound. So what's a lower bound to the graph? A lower bound to the graph is some horizontal line you can draw below the graph so that all points above it, the graph is always above it. So if you think about what's the greatest lower bound, what's the, it's pretty obvious that the greatest lower bound here is this one, right? It's y equals to 0. But nevertheless, it's not the global minimum because it's not actually attained. It's not reached by the graph anywhere. Now, I could do something stupid. I would say it's stupid. I don't know. You can say it's whatever you want to say. I can just go, I'm going to put a hole in the graph right here, and I'm going to define the function to be 1 right here. I mean 0 right there. Then the global minimum would be 0 because the function actually reaches it at that one point. That's why I said it's kind of a mean example.
Why would the electric be 0?
Just for the sake of discussion. But my point is, you approach asymptotes, but you don't actually reach them in certain circumstances. Now, that's not to say that a horizontal asymptote can't be crossed, right? There are other examples we've seen where we cross the horizontal asymptote. In this example, the horizontal asymptote is not crossed, though. So. Okay, so I'll let that stew with you guys. We can work more of these kinds of examples another day, but I'm going to go on to a word problem. Oops, over here. Why am I using this inferior eraser when I have a perfectly good shirt to use? All right. So here's the problem. You're given 400 feet of fencing to enclose a pen with two yards, but one side has lava, so the children don't escape that way. Oh, I'm sorry. If this is offensive, you can trade out the children for sheep and put the lava to be water. I don't know, whatever floats your boat. But so here we go. Lava, and then so we're building some kind of pen, and it has an enclosure. My point is that we're only putting walls here and here. The fence is only going here and here, right? Do you guys understand the problem? Oh, I'm sorry. Here, I'll make it better. Students. There. Is that better? Okay. You give them a test. Test A and test B. I don't know. Sorry. Okay, so the question is, what dimensions should I choose to maximize the area enclosed? Okay. Choose dimensions which maximize area enclosed. Now, if I'm not a glutton for punishment in my grading, I will label things on the picture for you. Like I will say, let's call this distance here, let's call this x, right? And let's call this distance here. Oh, is that bothering you? Should this be x? And this should be y? I don't know. I'll make this x and make this y. You do whatever you want. I'm doing that though. So x and y. What's the area then with that choice? So this, again, this, I know it's easy to lose track, but here's the problem statement. Now I'm going to solve it, okay? So solution, mostly in purple. First of all, the area is equal to x times y, right? I do expect you to know that area is length times width. I'm pretty sure this is not too much of an imposition of mine. What am I given? What's that? Yeah, 400 feet of fencing up here. Now, how does that relate to this? I need a formula for the length of fence used, right? In term 400 equals, what did you say? 3x plus y, right? And so right here, if you look at different variations of this problem, this is what will be different, right? If I make, for example, if there was no division in the middle and if there was no lava, you just have 2x plus 2y. And this thing right here is what always gets tweaked when you change the problem a little bit. I guess the area function could also be changed if you removed a little corner or whatever. Anyway, so that's the situation, right? There's something else, though, that's maybe worth emphasizing, is that x and y are assumed to be greater than or equal to 0. In fact, 0 is not really an allowed solution, is it? So for physical reasons, you think about it, we're really looking at x and y positive, or I guess we could throw in greater than or equal to 0. But so how do I solve this? I like what you're selling. I will buy it. Let's see here. So this is x times 400 minus 3x. So in other words, you said solve for one of the variables and plug it in to the area formula. Since we have a love affair with x, we will eliminate y. There it is. So my area function is 400x minus 3x squared. And there you go. Now I have what? I have a optimization problem. Now I just go back and kind of do what we were doing earlier today, find the critical points, and see what it tells you, right? So we set dA dx equals to 0, which dA dx gives me what? 400 minus 6x equals to 0. You actually worked this problem in college algebra if you had it here, but there you didn't have calculus. So how did you work this problem? Same song and dance, but you use the formula for the vertex for the step, essentially. But we figure out where the vertex is by looking where the horizontal tangent is. I mean, geometrically, the area function's an upside-down parabola, right? So it's got a peak somewhere. That's at the vertex. That gives you the answer. But we can find that by setting dA dx equal to 0. What does x equal to then? 400 is equal to 6x. So therefore, x is equal to 400 over 6, which is whatever it is. 66.6. Oh, 67, okay. Feet, was I using feet? Oh, feet, yes, okay. And then what's y equal to? 400 minus 3 times 400 over 6. 200. So the answer, I would say, is x equals to 66.67 feet, and y is equal to 200 feet. Those are the dimensions I want to maximize area. What is the maximum area? Say it again. I just didn't.
1,300, 334 feet squared. 13334.
Oh, okay. There it is. I would say this is probably this is, in my opinion, probably the go-to test question of this material. If you took a poll across 10 instructors of calculus, you'd probably find out that many of them were going to use this one. Let's look at number 10 in your homework. That was roughly speaking number 9. I'm sorry, I'll get out of the way here. Oh, but before that, I should ask you a question. An engineer, a physicist, and a mathematician, right? They're given a certain length of fence. You with me? Say 10 feet. And they're asked to enclose the maximum area. How do they proceed? Do you guys know? Well, the engineer says, I'll make a square. That's sufficient. That's scalable. It's a good value. So he'll make a square. Put a square. He's like, all right, there we go. There's a square. Physicist goes, I'll make a circle. A circle has perfect symmetry, right? That's what a physicist would do. What does a mathematician do? A mathematician, he puts the fence around him, any old which way, and then he says, I'm outside. So here's a picture of what just happened. Math person, fence, inside, the rest of the earth. So, I mean, what is inside and what is outside? Yeah. It's good. There was some laughing in here. I have told this joke before to college algebra and got no reaction whatsoever. Complete and total misunderstanding. It's okay if you didn't understand the joke. I mean, it's just a silly joke, but. What's that?
What does a physicist do on vacation?
What does a physicist do on vacation? I don't know. Goes a fishing. Oh, so horrible. So horrible. Goes a fission. Oh no, now I'm lightheaded. Good job. Oh, okay. Number 10 of homework. Number 10 seems appropriate. there a bug in here? Did I see something flying? No, it's just me. All right, good. For its beef stew, Betty Moore Company uses aluminum containers that have the form of right circular cylinders. Find the radius and height. Okay, so here's the radius, which I will call R. Here's the height, which I will call H. And find the radius and height of a container if it has a capacity of 43 cubic inches. The volume is equal to 43 inches cubed. That's given to us. And it's constructed using the least amount of material. So I'm assuming that this beef stew that they're shipping, they want a top and a bottom to the can. Seem fair? I think we would assume that we'd like to ship beef stew in closed containers, right? I mean, dogs might disagree with us, but so so we want to minimize the surface area is the point, right? So the question is minimize surface area of can. Because if you do that, that minimizes the amount of material that's needed to construct the can. Do we agree? So, what do we need to do? Let's say that F is the surface area, and F is equal to what? I mean, I guess we could use S. Why not? Here we go. Surface area is what? It's pi r squared plus pi r squared. What are those? Those are the caps, right? The base and the top of the can. And then what's the side? How much area is there on the side of the can? Do you know how to think about that? How do you make a can? You take a sheet of metal, right? And you roll it up. And then weld it along the join, right? Yeah, length times width. So you say 2 pi r times what? Times h, right? Because that's what you'd have. You know, you'd have the h, and then this would be the 2 pi r. And you can imagine folding it over. That gives you the vertical part of the can. Okay, so cleaning this up a bit, we have S is equal to 2 pi r squared plus 2 pi rh. And what else do we have? We have the volume, right, is 43. But what else is the volume? The volume is also pi r squared times h. So we only know how to do calculus of one variable at this point. At the end of the course, I'll teach you multivariate calculus, just a little bit, just a tiny smidgen. But we want to eliminate one of the variables, right? So which one? I mean, I want to look at S as just a function of R or just a function of H. I mean, you could go one of two ways here. Let's just pick a path. Let's solve for H. H is equal to what? 43 divided by pi r squared, right? So therefore, S is equal to 2 pi. I'm going to factor out how fine I won't. 2 pi r squared plus 2 pi r parentheses 43 divided by pi r squared, right? Now we have S as just a function of R, right? S of R is equal to 2 pi r squared plus, the pi's cancel, don't they? And we got 86 divided by R. Right. And now we can do calculus on that, right? Find the critical number. So look for critical radius, right? Because that's the meaning of it. So we do ds dr.